Hello and welcome to the next video in the online Paramics Workshop series. I recommend checking out the other videos that have been recorded in this series and which will be available on the YouTube channel. My name is Graham Smith. I'm an experienced Paramics modeler who often takes part in the regular workshops, and I use Paramics extensively. Now, unfortunately, my computer doesn't have a camera, so I'll just be recording my screen during this video. This video is pre-recorded, but is being premiered live on YouTube, so you can ask questions in the chat if you have any, and someone will be on hand to answer. We will also collate any questions that we have throughout the program and have a question and answer session at the end of the series. So as I said, in this video, we're going to be looking at highway modeling. So Paramics has been used to model highways in a range of locations. This includes highway corridor models, or highway models with route choice, or even mixture highway urban models where you have a motorway passing a city centre, for example, and you include both the motorway and elements of the city centre. And decreased runtimes in Paramics Discovery has meant that the scope for models, including highways, is wider than it has been in the past. So, as with any model, the first thing to do is to review your data and consider your study. So, when you include a section of highway, what are you trying to reflect? Is the highway a key part of your study, or is it on the periphery? You need to review what data do you have. Ideally, if your highway is important, you'll at least have journey time information for your highway section. Or alternatively, you might have queue information, even some videos recording the traffic conditions. And you also want to consider where the delays are on the highway, and if possible, what is causing them. The more information you can have, the better. So that gives you a clearer understanding of what you want to be looking at when you start creating your model. Now, in terms of the modeling itself, the first thing to consider is whether you want to use highway or urban links. So these are the two different basic types of links you can have in Paramics, and the names highway and urban relate to differing lane choice and speed behavior that is available in the model, and it's not an absolute definition in the geographical sense. So for example, you may have a stretch of motorway that, although it is motorway with a 70-mile-an-hour limit, the vehicle behavior on it is more like the urban style behavior you get in Paramics. So coding it as urban would be absolutely acceptable. So while you can use either urban or highway to reflect a highway situation, and we'll talk more about that later, the one thing you definitely don't want to do is to use a mixture of the two on the same corridor. So if you have a situation where you've coded your model and it switches on a link, on a stretch between urban and highway, the vehicles will change speed as they cross from an urban link to a highway link, or from a highway link to an urban link, and that change in speed can lead to phantom queuing, as any decreases in speed can cause shockwaves that go back and cause the queuing and unrealistic delay that you might see in a model. So the only thing to remember here is do not use a mixture of the two on the same corridor. So first of all, if we look at highway links and why you might want to use them. So with highway links, you get what I'll call a highway style speed distribution. And that is slower vehicles stick to the inside lane and faster vehicles will overtake them using lanes 2 or 3 or higher, depending on the number of lanes you've got. The highway links also allow you the use of the ramps function in Paramics. So the ramps function is a way of connecting the rest of your network to your highway, and when you use a ramp function, you get the courtesy move out for ramp behavior, which is when vehicles on the main line, if they see a vehicle joining on a ramp, will try and move out from lane 1 to allow there to be a gap for the vehicles on the ramp to merge in. But if you use highway links, there are a couple of potential issues. So vehicle lane choice can be problematic in situations, particularly where you have numerous junctions in close proximity. There can also be problems with ramps where you have high flow levels, where the flows can break down around the ramps at a higher rate than they would do with urban links, which we'll discuss in a second. So as I said, urban links is the other option. On urban links, vehicle lane choice is better in complex situations. So where you have multiple junctions close together, urban links are often more useful. And although you can't use the ramps function, because that's for highways only, you can reflect ramps using an alternative coding method, which I'll show you in a second. And this alternative coding method has less flow breakdown and can cope with a higher flow before you start seeing problems, which can be more realistic. But with urban links, the vehicle speed distribution is different. So broadly, you won't get such a wide spread of speeds as you do on highway links. So more vehicles will be traveling at or near the speed limit on urban links. And you also do not get the courtesy move out for ramp behavior because you can't use the ramp function. Here I've got this model, and this top section here is a highway coded with urban links, and this bottom section is a highway coded with highway links. So on the highway one, I've used a ramp to connect the rest of the network to my highway. You can see the orange node there represents that ramp has been used. And in my urban section, I've used the alternative coding method. So if I just show you what that is, if I zoom in here, so you can see my highway main line is 3 lanes, and it's 3 lanes either side of this merge. And all I've done is where I've got my ramp is I've got a node here, which is for me node 3, and it's just simply a junction joining these 2 links together here. And for this section of merge, which is shown here, I've added an additional lane. So I've got 4 lanes here. So that replicates the vehicles getting a chance to merge in for a section to the highway mainline traffic. And then it narrows back down to 3 lanes afterwards. You'll also notice that I've used next lanes across this node, and that's because I don't want vehicles coming down the ramp and jumping straight across onto the main line. I want them to go into the merging section. And similarly, I don't want vehicles on the main line to jump across to the merging section. I want them to stay on the main line. And in order to help that, I've also want to make sure that my narrow hazard, which is here, extends back far enough so as that vehicles at this point can see it. So if vehicles can't see this narrow hazard when they cross this node, then they might start switching lanes into what I'm calling the merging section here, which obviously is unrealistic. So if I just click on this narrow hazard, I can see the shading showing that it does extend back. And as the default hazard length on urban links is 250 meters, in all likelihood, you will the the widen here will fall within 250 meters, so you'll probably be okay, but it is worth checking. So this is the coding method I use to replicate highway ramp behavior on urban links. So I've got the same amount of demand on both of these two sections. So if I just go to visualize and play it, first of all, we'll look at the highway section, and what you can see, I might just slow that down a bit actually. Start playing, there we go. So we've got vehicles coming down the ramp and they merge into the traffic as they get a gap. And I've replicated this up here using this additional lane, and what we should see is a similar thing happening. Yeah, we can see vehicles coming down the ramp and then merging in as they can. So the behavior of this urban style coding is very similar to the ramp behavior to look at. So this looks absolutely fine and is a perfectly acceptable way of coding a highway merge situation. I did mention that in high flow situations, it can be that the ramps on highways don't necessarily reflect behaviors as well as urban links do, and you tend to get more flow breakdown. So the demands I've got here are quite high. So if I just turn the speed up and let that run in a bit, what we'll see if we stop in a second is that if I look at my highway section and go back to the zone, I can see I've got 171 unreleased vehicles. And if I watch it run, you can see quite a lot of stationary vehicles, a lot of queuing, and that unreleased vehicle number going higher and higher. Whereas if I go up to the urban version of the coding and play that, I can see there's much less delay, and the operation of this merge is much better, or much more efficient than the highway version, and I'm not getting any unreleased vehicles at all. So in terms of high flow situations or potentially high flow situations, so you might want to future-proof your model if you're planning on adding growth or development traffic, then often using urban links is much better for those sort of situations. So the next thing we want to consider is hazard lengths. So we want to ensure hazards are long enough to give vehicles traveling at high speeds time to react. So the way that vehicles react to hazards is different on urban links as opposed to highway links. On urban links, once vehicles reach the signposting for a hazard, they will start to react to it. Whereas on highway links, they will react in a spread around the signposted point. So you can have vehicles on highway links that react to a hazard before the signpost distance, whereas on urban links they're always after the signpost distance. So by that token, on urban links, you want to extend your hazards back to near the start of a long link. And the reason you want a long link is because vehicle lane change behavior in Paramics is much better over links than it is over nodes. So you want to give the vehicles as much link space as possible to change lanes rather than over nodes. If you get a lot of vehicles changing lane at nodes, you can get phantom queuing. So on urban links, you want the hazard to extend back to near the start of a long link, and on highway links, extend back towards the middle of a long link. And that will really expand on or really maximize the capacity or the available space for lane changing for vehicles. Also, alternatively, if you extend back into a zone, that is also acceptable in certain situations, because then all the vehicles that load at that zone will already be in the correct lane. So if I show you what I mean with these hazard lengths, go to another example. So what we've got here is, again, two models identical, one coded in urban and one in highway. So if I click on this node, and I've got my hazards turned on with H, click on this node, it shows me the signpost distance for this hazard. So this is the default. This should be at 250 meters. It is. So because this is urban, the default's 250. Now that's really not very far in a highway situation. So if I go to visualize, I'll show you what I mean here. Just refresh that, and I'm going to turn on vehicle marking and mark any vehicle going to zone 5, which is this one in yellow. And excuse me, just open that back up. So what we'll see here is this vehicle is in lane 3 and has just realized that it needs to be in lane 1 to come off at this junction. So it knows its lane range is now 1-to-1, but it doesn't have very far to make those changes, especially because in this example it's very busy, and it's going to just switch over and cut across 3 lanes in order to exit. You'll see some potentially less good behaviors from vehicles with this signposting. Like, here's another one. This yellow vehicle is going to cut across quite late and cut in front of vehicles. So it knows it needs to be in lane 1, but it hasn't got a chance because 1, the link is busy, and 2, it's not got very long to make that change. So what I want to do is make sure I extend that hazard back. And in reality, chances are the signposting on the ground for this turn will be much earlier than shown here. So what I want to do is have it go back to the start of a long link. So I'm going to pick this preceding link, and I'm going to change my signpost distance to 1100 meters. So that's just in the properties of the node up here. And I'm going to, if I go to visualize now and refresh and play, if we get one of these vehicles and follow it through. So it's now realized all the way back here because I've increased the signpost distance that needs to be in lane 1, and it should have more time to move across. So there we go, it's moved across to lane 1. And in fact, you should see, I'll slow it down a bit so it's easy to see. By the time we get to the exit, all of the yellow vehicles have made it into lane 1, and you don't have the cutting across. So we want to make sure that vehicles have enough time to get into lane. And we want to make sure the hazard on an urban link goes back to near the start of a link. Now with highway links, the default is 750 meters. So that's already quite far back. And in this instance, the hazard, the signpost distance point is quite near this node here. So all I'm going to do in this instance is I'm just going to increase this to say 900 meters. And what we'll get then is the hazard goes back to about the middle of the link, and you'll get a better spread of reaction around this hazard, and vehicles should react appropriately. And the next thing we want to make sure we always include as a starting point is headway factors. So when there's merging going on and lots of lane choice, we want to reduce the headway factor to allow the gaps between vehicles to be a bit smaller on those links. So there's 2 locations that we want to apply headway factors to as a default, and that is on the merge links themselves and on the links onto which the hazard extends back. And the headway factor we use as a starting point is 0.6. So if I show you what I mean, if I go back to this model, what I'd want to do is put headway factors on the link onto which the hazard extends back. So the link where you expect the lane changing to take place. So that is this link here in this instance. So I'd put a headway factor on this link of 0.6. And similarly, this hazard I've got extending back to this link, and again I'd want to use a headway factor of 0.6, and that'll just ensure the lane changing on these two links here will be a bit smoother. Similarly, on my other models, my merge models, I want to have headway factors on the links where the merges themselves take place. So in this case, it would be this link. So again, headway factor of 0.6, and on this one, also a headway factor of 0.6. And again, that just improves the lane changing behavior on those sections and gives a more realistic model of what's happening. And these are only starting points, so these can be refined further, but I would always recommend doing these by default. And as mentioned, you want the vehicles in these highway sections to change lanes on the links because the lane changing behavior is much smoother than it is across nodes. And as a result, putting in next lanes across nodes can be very useful just to stop vehicles from changing lanes at the nodes, because that can lead to phantom queuing. So don't be afraid to put next lanes across nodes to prevent lane changing at these points. And some other things to consider are you may want to, in fact, you probably will want to put speed limit by vehicle type or by link category, so you can limit the HGVs to top speeds of say 60. Either you can do it either in the vehicle type settings or in the link category. You also can include lane restrictions, so you can set up a lane restriction which prevents heavy vehicles from using the outside lane. So quite often on 3-lane motorways, heavy vehicles don't use the third lane. So setting up an HGV restriction and applying it to the third lane can be very useful and give a more accurate representation. And then once you've included all of these things, and if you're still not getting the lane choice behavior or lane changing behavior that you want, then you can start looking at additional things. So if your lane choice isn't correct, you can start looking at hazard overrides, but again, make sure everything else is correct before you start using hazard overrides, because you want to ensure that your basics are right before you start overriding it. And then if you're getting too much queuing still, then the next thing to consider is further headway reductions. So this can be either lower headways on the links on which you've already got headway factors, or headway factors on other links as well. So in summary, consider what it is you are trying to model. Decide whether you want to use urban or highway links, depending on which will be more appropriate. Check and alter your hazard lengths and signpost distances. Add in headway factors at points where you expect there to be significant lane changing. Consider using next lanes to prevent lane changing across nodes, and add in speed limits by vehicle type and HGV restrictions to outside lanes where appropriate. Thanks for watching, and I hope that's been helpful, and please comment or send us any questions about any of that, and we'll hopefully be able to respond.